In this example, we're going to be finding the determinant of the following 3 by 3 matrix. Matrix A is equal to 1, 4, 7 across the first row, 2, negative 3, 6 across the second row, and 5, 1, negative 2 across the third row. We're going to do this using cofactor expansion. Now, when it comes to cofactor expansion, you'll be responsible for selecting any row or any column and multiplying the corresponding entry by its cofactor. Now, what I'd like to do in this example is demonstrate that it does not matter which row or which column you actually pick here, that you should get the same result either way. So for this first one, I'd like to expand across the first row. So the determinant of A is going to be equal to the 1, 1 entry multiplied by the 1, 1 cofactor, plus the 1, 2 entry times the 1, 2 cofactor, plus the 1, 3 entry times the 1, 3 cofactor. So for the 1, 1 entry, that's going to be 1, and the 1, 1 cofactor would be the same as the 1, 1 minor. So we eliminate the first column and the first row and just worry about this little guy right here. So that'll be negative 3, 6, and 1, and negative 2. Now for the 1, 2 cofactor, because this is in an odd position, as it were, the cofactor will wind up with a negative in front of it. And we eliminate the first row and the second column and take the determinant of that minor. So 2, 6, 5, negative 2. Then for the 1, 3, we have an even here, so this will be plus 7 times, eliminating the first row and the third column now, we'll see 2, negative 3, 5, 1. So the result is a total of 3 2 by 2 determinants, all of which can be evaluated using the proper little slashy technique. So multiply the main diagonal together, negative 3 times negative 2 minus, and the other slash would be 1 times 6. And we'll do minus 4 times 2 times negative 2 minus 6 times 5. And then we'll do plus 7 times 2 times 1 minus negative 3 times 5. Now this, of course, can be simplified according to the order of operations. Good news is that in this first guy, we're going to have 6 minus 6. So 6 minus 6, that's good news. In this one, we'll see negative 4 minus 30, a little more complicated. And then in the last one, we will see 2, and that'll wind up being plus 15. So overall, I am seeing negative 4 times negative 34. Well, sorry, one at a time here. I'll do 1 times 0. Minus 4 times negative 34, plus 7 times 17. Apparently I felt like giving myself a bit of a challenge in this problem. So that's 136 plus 119. 36 and 19 is 55, and 1 plus 1 is 2. Okay, so 255 for this determinant. Now what I wanted to do was demonstrate that it doesn't matter which row or which column you pick, you should get the same result either way. So for this next one, I'd like to expand down. We'll do the second column. So what I'm going to be setting up is that the determinant of A is equal to, this will be the 1, 2 entry times the 1, 2 cofactor, plus the 2, 2 entry times the 2, 2 cofactor, plus the 2, 3 entry times the 2, 3 cofactor. Now, it's just off screen now, so let's pull it back on. So again, going down the second column. For the 1, 2 entry, because we have the odd index here, this will be negative 4. Oh, actually, this will be the same thing as our middle term from the last one. So 2, 6, 5, negative 2. Then for the 2, 2 entry, because it has an even index, that'll be plus. However, the entry itself is negative 3, so that'll introduce another negative sign. Then the 2, 2 minor we get by getting rid of the second row and the second column we'll see 1, 7, 5, negative 2. 1, 7, 5, negative 2. Then for the 2, 3 entry, we see that odd index, so this will be minus. The entry is 1. And associated with that 1, we'll be getting rid of the second column and third row and evaluating that minor. So that'll be 1, 7, already lost track of it, 2, 6. Cool. So as I'm continuing to expand this, what I'd like to do is demonstrate that we're actually going to see exactly the same things multiplied together here. So negative 4 times 2 times negative 2 minus 6 times 5. Of course, this one was the same as the middle entry from our last determinant, so we don't have to give that one a lot of energy. We'll see 1 times negative 2 minus 7 times 5. And for the last one, that'll be minus 1 times 1 times 6 minus 7 times 2. Now what I could do is just go ahead and evaluate this using a whole bunch of arithmetic, but I wanted to point out a few things. First off, we already know that this whole big term, and apparently my purple pen doesn't want to write today, is the same as this whole term right back here. Other things that I would like to point out is for this term, we'll have a negative 3 times 1 times a negative 2, which is technically what we had right back here. 1, negative 3, negative 2. For this one, we have negative 3 times 7 times 5, and it's being subtracted. We have that same thing right here in the other one if we were to distribute that 7 through. Then we have a minus 1 times 6 right here, which we see right here after we were to distribute that 1 through. And finally, I don't have another way to do this, so we'll just use circles. This is minus 1 times minus 7 times 2, and we see that is essentially what's going on right here in the previous term. So after distributing everything, we're going to see exactly the same numbers all being added together. So I'm going to go ahead and do that all in my head and certainly not reference back to this number right here, and we'll get 255. So, long story short, pick any row, pick any column, it should be the same result regardless of the one that you pick. We'll use decisions like this to help influence which rows and which columns we'll pick in future problems.